Alright, let's look at the homework 6.2, problem number 1. Right, so we want to find the volume of solid of rotation obtained by rotating the region bounded by y equals 4 square root of 16 minus x squared, y equals 0, which is the x-axis, and x equals 1, x equals 2, about the x-axis. Right, so let's do that. First, let's choose the region, right? So it's square root of 16 minus x squared is just the upper semicircle with radius 4. Then you multiply by 4, so it's going to be stretched by a factor of 4. So it should look like either second picture here or third picture, right? But since boundary lines are x equals 0, which is the x-axis, and x equals 1 and x equals 2, so those are a couple of vertical lines. So you can see that here, this is x equals 1, and here's x equals 2, and here's the x-axis. So this is the correct picture. All right. Then the region is obtained by rotating about the x-axis. So you can see that that picture is going to be, right? So let's see, they look kind of similar, but if you rotate this region around, you see that you have something like the first one looks promising. Not the second one because it's tilted this way. So, and fourth one is not going to be it. And this one is also promising. And let's see, what's the difference between first one and the third one, right? So looks like, let's see, and 1 to 2, 1 to 2, and the fourth one has a hole in it. All right, so looks like this one is the winner. All right, so let's go ahead and check to see if we got the correct region, and by submit for testing. Hold on a sec. Okay, I'm gonna just pull it down. All right, submit for testing. All right, so we got the correct region and the correct solid. All right, so we just need to find the volume from here. So I'm gonna just steal this picture and then set up the integral and find the volume. All right, so we can use the disk method to set up the integrals. So volume V is equal to, all right, so disk method, start with pi and the integral, and it's going from 1 to 2. So it's a 1 to 2. Alright, then you would have to find the radius square. So you have a radius squared. Alright, then this is with respect to x. Alright, so you can see that the radius is going from the x-axis all the way to the edge here of the semicircle. So whose equation sits right here. So that's going to be the radius. So we have radius, which is 4 square root of 16 minus x squared. Then we have to square this. Right? So this is going to be equal to, right, pi, right, integral from 1 to 2. Right, we have to square 4, so it's going to be 16. Right, actually this can be placed in front of the integral, so I'm going to actually put the 16 right here. Right, then you can see that the square root and the square cancel out, so you're going to get 16 minus x squared with respect to x. Right, find the antiderivative. 16 pi is still there. Antiderivative of 16 is 16x. antiderivative of x squared would be x cubed over 3. Then you're going from 1 to 2. Right, so this is going to be 16 pi. Right, then plug in 2, so 16 times 2 is 32, minus 2 cubed is 8 over 3, minus, plug in 1, 16, minus 1 cubed. Alright, so you can just change that to bracket there. Alright, so this is going to be 16 pi. Alright, so I'm going to combine 32 and minus 16, so that's 16 here. And minus, alright, so negative 3, 8, and you're going to add negative 8 thirds, and we're going to add 1 third. So it's going to be minus 7 thirds. Right? So this is going to be 16 pi. Right, taking a common denominator, so it's a 3. So 3 times 16 would be 6 times 3 is 18, and 48 minus 7. So this is going to be 16 pi times 47, so 41 over 3. Right, so what's that? Let's see, 16 times 41 is, let's say 16 and 24 and 4, 656. So you have a 656 pi over 3. Right, so that's the volume. Right, so let's type it in. Right, so what we got was 653. All right. Oh, actually, whoops, sorry. 656 pi over 3. All right, is that right? Yep. So, all right, let's double check. And I'm going to just submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.